In this video, we're going to do a few examples of finding the inverse function. So first I'm going to do it using a graph. I'm going to find the inverse function using a graph. Then the next ones we're going to do it algebraically, and then we'll also sketch graphs. So first let's get started with part A. Find the graph of f inverse from the graph of f. Alright, first let's verify that this is indeed a function that will have an inverse. And we can do that with a horizontal line test. So we see, yeah, this function, if this is f, maybe I should label it as f. So if this black line is f, then this will have a function because it passes the horizontal line test. Okay, so now let's go ahead and start finding the inverse. So remember, inverse functions basically they flip whatever x and y are. Okay, so let's start with this first point here. 1, -3. Okay, so now instead of it being 1, -3, now it's going to be -3, 1. So flip x and y. So I'm going to do this in blue. So x will be -3, y will be 1. So that's here. So I'm going to label that -3, 1. Next point is 2, -2. So now it's going to be -2, 2. So that point will be here. -2, 2. Okay, the next point is 3, 2. So that's going to be 2, 3. So 2, x will be 2, y will be 3. So that will be here. So this will be 2, 3. Alright, the last point is 4, 4. Well, that will stay in the same spot because if you were to flip it, you would have 4, 4 again. Okay, so I'm going to go ahead and draw this. Let's connect the dots. Okay, and so you might see something. You see something kind of interesting here. So say I were to draw the line x equals y. Okay, so I'm just going to draw a dotted line. This is the line that x equals y. So what you see is that the inverse function, which is this blue line, so this blue line is the inverse function. This is basically, a reflection over the, the origin, the x equals, or y equals x, okay? So if you were to, kind of reflect this over, you would have the inverse function, okay? So if you had just the shape, if you just kind of think about folding the paper here, and then putting it on the other side, putting the function on the other side, that's how you get what the inverse function looks like. Okay, so now let's check or find the inverse of this function algebraically. Okay, so not by using graph, but by using our algebra. So first step is always going to be to check that f is 1 to 1. So this should always be your first step. So to do that, I'm going to plug in x1 and x2. And then if x1 equals x2, then the function is 1 to 1. And so let's go ahead and do this check. So I'll have 4 minus x1 squared equals the negative square root of 4 minus x2 squared. So again, we're checking if x1 equals x2. So I'm going to go ahead and solve for x1, and then we'll see if that equals x2. So I'm going to multiply both sides by -1, get rid of the negative sign that's out there, 4 minus x2 squared. I'm going to go ahead and square both sides. So I'll have 4 minus x1 squared equals 4 minus x2 squared. And I'm going to subtract 4 from both sides. Okay, so now let's move on to another example. So in this one, we're trying to find the inverse of 9 minus square root of x, and then we're also going to sketch the graph. So let's go ahead and get started with this. Step 1 is always to do the check that f is 1 to 1. That's always going to be your first step. So we'll do that algebraically. We'll plug in x1, and we'll plug in x2, and then if x1 equals x2, then we know we have a 1-to-1 function. So 9 minus the square root of x1 equals 9 minus the square root of x2. Okay, so I'm going to go ahead and add or subtract 9 from both sides. Okay, the goal is to solve for x1. Okay, take or multiply both sides by -1 to get rid of the negative sign. Okay, then go ahead and square both sides. Okay, x1 equals x2, perfect. That is a 1-to-1 function. Alright, so now we can go ahead and move forward to step 2, which is to find the inverse. Okay, so now let's go through the steps to find the inverse function. So this is step 2. So we have f of x there, so let me just write that. F of x equals 9 minus the square root of x. The first step is to replace f of x with y. Okay, and then inverse functions basically flip x and y. So the next step is to flip x and y. Okay, so switch x and y. And then now we need to solve for y. That's the next thing. So to solve for y, let's see. First thing I'm going to go ahead and do is I'm going to subtract 9 from both sides. So I'll get x minus 9, and then this 9 will cancel, so I'll have negative square root of y. I'm going to multiply both sides by -1 to get rid of that negative sign. So I'll have negative x minus 9 square root of y. I'm going to go ahead and distribute that negative sign. So I'll have negative x plus 9, negative x plus 9 is the same thing as 9 minus x. So I'm going to write that 9 minus x. Okay, that is the square root of y. Okay, I'm going to square both sides. So I'll have 9 minus x squared equals y. Alright, so then last step is, y is now f inverse of x. So I'm going to go ahead and write that. F inverse of x equals 9 minus x squared. Okay. One thing, so what is the domain of f of x? So the domain of f of x, let's go ahead and write this. So the domain of f of x, so we have 9 minus the square root of x. So inside the square root you can't have negative. Okay, so the domain of f of x, it would be 0 to infinity. Okay, so now what's the range of f of x? So the range of f of x. In this case, it's kind of easy to see that the range of f of x, so this square root of x will always be a number that is greater than 0, right? Like I can't, put in an x value and get, the square root of x to equal -1, for example. There's no value, no real number at least, that I can put in for x and get -1. So, the range, so this 9 minus the square root of x, the highest this will ever be is 9, because it'll be 9 minus 0. In terms of how low it can go, well, x can be a really large number, which would make 9 minus a really large number a really negative number, right? 9 minus a really large number is a really negative number. So the range would go from negative infinity, but then as high as it could possibly go is 9, and it would include 9. Okay, so earlier when we were talking about the properties of inverse functions, we mentioned that the range of f of x is the same as the domain of f inverse of x. So the domain here of f inverse of x would then be -9, or negative infinity to 9. Okay, and then the range for f inverse of x would be the same as the domain of f of x. So it would be 0 to infinity. Okay, so now the last step is to sketch the graph of f of x and f inverse of x. Okay, so I've written here both of the functions and then the domain and range of each. All right, so let's go ahead and first let's graph f of x. Let's do this using transformations. So we know that if the square root of x looks something like this. Okay, so this is the square root of x. So I'm going to have, the negative in front of the square root of x. So, so basically, so 9 minus the square root of x, this is the same thing as negative square root of x plus 9, right? And the reason I want to write it like that is because I want to see this negative in front here. And so that's going to flip. So that's going to flip the graph. So this is the negative square root of x. That's what that looks like. And then plus 9 moves the graph up 9. So instead of it starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 9. So instead of it starting at 0, it's going to start at 9. Okay, so the graph of f of x is going to be a downward curve like this. All right, I'm going to erase some of this to clean it up a little. So this is the graph of f of x. All right, now to do the graph of f inverse of x, we can think about flipping this, or folding where I've drawn this line y equals x. If I were to fold it here, I would, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would have a point at 9 on the x-axis, and then I would have, a graph that would would come up from there. Okay. If you don't, if you can't see that by, imagining you're folding your piece of paper, you can always graph this by using your transformations as well. But if you were to do that using your transformations, you need to remember that you only have one side of the graph here, that your domain, so for x, you go from negative infinity to 9, and so you stop here at 9. Here's 9. And then you need to make sure that your range also goes from 0 to infinity. So if you were to use transformations, you would maybe accidentally graph the other side of this parabola. So you just need to be careful that you don't do that because you're restricted by your domain here.